So we're live. Probably. Someone's gonna have to tell me. I'll just wait. I'll just wait here, waiting for someone to tell me if this is actually happening. Guess I should warn my wife. It started. There we go. It's got to be working. Hey everyone, how's it going? Welcome back to another open space. In that I just sit in front of the camera and yak at you for an hour. So no guest this week. And I kind of feel like that's fun too. That when I have a guest, I'm so interested in talking to the guest that I don't have time to really incorporate a lot of your questions. And I still need to figure out how to do that, to not be so greedy. Because I'm like, oh, this is, if I'm talking to Jean-Michel Gaultier or a scientist, right? I've got a bunch of questions. And so I'm just like, just can't stop asking them questions. So with this, with just the one-on-one, then I can just hang out and only pull from your questions. So let's do that. And then maybe I'll just do this on a regular basis, because I could probably fill up the schedule. And I know like Nancy and team would love to book as many guests as we could. So I think it's kind of cool to just hang out and just do just us. All right. Let's see. He's next to me giving me a nudge. All right. So where do you want to start? What do you want to talk about? What's on your minds? All right. So Cameron Kotu's asking about the Raptor engine being updated to make use of 300 series alloy, hotter burns, higher pressures, higher thrust. I have no idea. That sounds like a Scott Manley question. Speaking of, before people were like, Fraser, Scott, fun space YouTubers. Scott Manley is a machine. He's a beast. He knows so much about space flight and rockets and material science and physics. I appreciate being in the same world as Scott, but I have mad respect for what Scott does. So Avi Scott and Flowers saying talk to Avi Loeb again. So for Avi Loeb, that's Abraham Loeb. He works at the Harvard Smithsonian Center for Astrophysics. He's the one who has been talking about Project Starshot and that Oumuamua could be a solar sail, and he's been in the news a bunch of times. I actually am incorporating some of his research into a new video that I'm working on all about the habitability of red dwarfs. And so he just released a paper called Photosynthesis on Habitable Planets Around Low Mass Stars. And the gist is there isn't enough of the right photons falling on planets around red dwarf stars for them to be habitable. And so he just works on everything, and he's just a hoot. And he's been in the media a lot now, and I think that it's pretty funny because he's like, a lot of scientists are getting really annoyed by him talking about things like alien civilizations and interstellar probes and things like that. And on the one hand, I totally understand, right? It gives science a bad name for talking about this stuff with a straight face. But on the other hand, whether or not there are aliens in the universe is a scientific question, and it is worth investigating that scientific question to try and test the limits to the point that at someday we're going to be able to actually find out the answer to this question. And so now is the time to figure out what it will take for us to be able to answer this question. So, and Avi Loeb is just so available and accessible, and he's just like the perfect combination. Some other people that are kind of like that, like Mike Brown from Caltech, who of course is the discoverer, the future discoverer of Planet Nine, is both like a really good scientist, but also just a great guy and really accessible and wants to help promote science. So there's a lot of those people. I would love to know some of the other guests who you would love to have come back and talk to. But I'd love some new people, right? I'd love, people working on the chime instrument for fast radio bursts, which is the next episode. Things like that. So anyway, I rely on you to remind me of people that you want us to talk to and incorporate into the videos that we do. Okay, the creator of TNT says, assuming infinite electricity on a ship, could they use light as a rocket engine shooting photons out the back? Could this go interstellar? Yeah. So what you're talking about is a thing called a photonic drive. And we talk about lasers shooting light sails or shooting solar sails, and the solar sail receives the kick, the momentum from the photons and accelerates. By the way, my voice is kind of going, so I'm not going to be super hyped. I hope I can make my voice last for this hour. So you get this kick from the photons, and they push the light sail as it moves through space. And the reality is that the laser that's shooting the photons is actually going to be receiving a kick in the opposite direction. And you could, of course, harness that, and you could make the laser accelerate and accelerate, and you could go up to the speed of light, like not actually the speed of light, but almost to the speed of light. And so it's theoretically possible. And you just said, like, assuming electricity wasn't the problem, then would it work? Yeah, except the electricity is the problem, right? You need a way to generate enough electricity to convert into laser power to be able to shoot the photons out the back, to be able to get the acceleration that you require. Where are you going to get that electricity from? That's the problem. So, theoretically. I see Pad Astronomy just dropped in. Christian Reddy. He has provided a fantastic answer to a question for a question show that's coming up next week. So stay tuned for that. F19 Steven. Hey, Fraser, as a Canadian, what do you think of the future of the Canadian Space Agency should be? That's a great question. I'm very proud of what we do here in Canada, and it feels sort of like the right role, right? We don't have a big enough population, big enough science budget to support our own spacecraft, but we support a lot of other projects. We provide the Canada arm and the version of that for the International Space Station. We provide instruments for other missions. We provide wonderful astronauts, like Chris Hadfield, right? And then as well in the astronomy world, right? There's the Gemini telescope, which is part Canadian, and there are other instruments as well. So I'm pretty happy with that role. I think for us to get involved in projects that other people are working on where they can use the expertise of Canadian scientists to help get the work done. And in the future, if we had bigger budgets, we could do our own spacecraft. But I think being a support role for other people is great. And I love the idea of nations working together around the world to carry out some of the more complicated programs that are going. I mean, for all of its boondoggleness, the International Space Station is an example where nations can work together. I'm not sure the total number of countries that worked on the International Space Station, but the fact that Russia and the United States were the major partners to bring this station together, plus the Europeans, plus the Japanese, plus us, is amazing. And I hope that future space missions will be like that. NM. Hi, Fraser. Do you think that Elon Musk will stick with the plan with sending humans on Mars by 2024, or will be the same problem with James Webb? I think it's really important to understand that anytime Elon Musk says anything, the timeline is totally out of whack, right? That the Falcon Heavy, even the Falcon rocket's landing, and of course now where we're at with the Starship and the Super Heavy, they have taken a lot longer than Musk and SpaceX ever anticipated that it was going to take. That said, anyone who thinks that Musk is just a dreamer can just watch the rockets landing from the Falcon Heavy, the twin rockets landing side by side, and just watch that on repeat until your resistance has been broken. Right? Like, they are moving forward in ways that have never been seen before. So do I think that humans are going to be off to Mars by 2024? No, I don't think so. Here we are, 2019 now. So many technologies are in the works. That said, the work on the Starship and the Super Heavy have been coming together faster than I really anticipated. The fact that the Starhopper prototype is already built, assembled, and we should see tests within a couple of months now, maybe even several weeks, is amazing. Of course, what is it really, right? It is a fuel tank, a bunch of Raptor engines with a water tower, and the thing's going to take off, hover for a bit, and then it's going to land. So that is vastly different than what the actual Starship and the Super Heavy booster are going to be in their final iteration. And there's a lot of things that need to be figured out. So I think that, and then you've got to figure out all of the other technologies to be able to keep people alive on the trip to Mars, to land at Mars, to build colonies on Mars, where people are going to go to the bathroom, how are they going to grow their food, on and on and on and on and on, right? All the engineering challenges. So my guess is it's going to take longer. And I think that as the first spacecraft do go to Mars, people are going to learn whether or not they actually want to colonize Mars. Like, I think, there aren't a lot of good reasons for Mars to be colonized, in my opinion. We don't need a backup of Earth, right? If we lose Earth, no backup is going to help us. Earth is the best. So I think Mars is going to be a really interesting place for us to go and to scientifically study, and a very extreme environment for a lot of people. But I do think that when the Starship is ready, I actually suspect that people are going to be less enthusiastic about moving to Mars. But we'll see. All right. Thanks for everyone using the question mark. And Avi Scott and Flowers says, will I go see the Starship's first launch and do a stream? I'd love to, if I can get the invitation and go see it. I've only seen one rocket launch so far, and that was a fairly small rocket, the one that carried OSIRIS-REx. It was an Atlas V. To see like the Delta IV Heavy that carried the Parker Solar Probe, or the space shuttle. I tried to watch a space shuttle launch, but it got delayed, so I missed that. But to see a really super heavy rocket like a Saturn V or the new SLS, that one, I'm looking forward to the SLS if that ever gets off the ground. Bill Seidel is noting that the moon is looking really nice right now. And of course, we are in the quarter moon right now, and we are just a week away from the full moon. So we're going to have a full lunar eclipse on the 20th, the night of the 20th. And it's going to be perfectly positioned for everybody in North and South America, as well as some folks in Africa and some folks in the Pacific Ocean like Hawaii. So if you are anywhere in North America, South America, make sure on the 20th you go out and watch the lunar eclipse. I'm going to be doing a live stream, I think, partnered with Oceanside Photo and Telescope. They're going to supply some gear, and we're going to try and do like the best possible live stream that I can wrangle of the lunar eclipse, for the 4 hours that the thing goes on for. So still trying to figure that out. So stay tuned, and I'm sure I'll put a link when we actually get that organized. Rami Emad asks, is the future of space for bigger, huge projects and missions, or the smaller and almost Copenhagen suborbital like? It's a good question. So the question really is, is the future about super heavy lift vehicles, or is the future the smaller lift vehicles? And I think a lot of that's going to depend on our ability to acquire resources and manufacture things in space. If you can launch a self-replicating robot probe or something that can go and mine material off of asteroids and help distribute them back into Earth orbit, and then start to assemble things in space, then you actually don't need a ton of launch capability to get off of the planet. You just launch the bare minimum, and it bootstraps the rest of it while it's out in space. But if that takes longer and is a lot more difficult, then you need to launch that stuff from Earth. But ideally, you don't want to launch any cargo from Earth. It's too expensive. It's too much of a pain. You want to get the stuff that's already out there in space and just put it into shapes that are a lot more useful for human beings. So I can imagine in the short term, we have this age of super heavy spacecraft, super heavy rockets. And then over time, as our orbital infrastructure gets better and better and better, our need to launch things will go away. And all that we're ever going to want to launch is probably people and really complicated manufactured goods. But those won't require gigantic amounts of mass. So it really just comes down to the amount of infrastructure that we can get into space. NM is asking what telescope I have. That is a Stellar View. It's a 70 millimeter refractor on a scientific instrument. Stellar View refractor on a scientific instruments mount. And it's a very nice telescope, and I don't use it because it's very complicated. And so I'm actually a big fan of not getting that kind of a telescope in the beginning, especially if you just want something that you can see in space. You want to get a Dobsonian, which is like they call it a light bucket. Get an 8-inch Dobsonian telescope. You can get one from all of the major manufacturers, Meade, Celestron, Orion, and they're very simple to use. They have a lot of light gathering capacity. They're completely manual, and you just, when you see something in the sky that you want to get a picture of, you just move the telescope over there and look through the eyepiece, and there it is. And the problem is that you can't do really good astrophotography with it. It's really just for looking through the eyepiece. And so you can see things like Saturn and Jupiter and the moon and Venus and some of the brighter objects, deep sky objects, like some globular clusters and some planetary nebulae and some of the galaxies and things like that. But the problem is, like, there's maybe, if you live in pretty dark skies, there's maybe 30 or 40 objects that you could see with a Dobsonian. And then after that, you want to shift to something like this, which allows you to do astrophotography. And so that's sort of the growth. Cosmic Lettuce is saying the sad thing is that the telescope doesn't get used. The reality is that because I have access to these virtual observatories with Oceanside Photo and Telescope, they're so much better than this telescope, and I can sit here at my desk and operate these amazing telescopes. So it just, every time I'm like, oh, do I really want to take that thing outside in the cold and do some observations, or I just want to access the amazing telescope that's down in Joshua Tree right now? I go the latter every time. So it's Dustin at Oceanside Photo and Telescope has completely ruined me. And I hope to, in fact, I'm probably tonight going to crank up the telescope if the weather's nice and do that later on tonight. So if you guys are interested, I will probably be around even later. I'll probably do that on Twitch as opposed to here on YouTube, but go to twitch.tv/fcain and if you haven't already, subscribe to that, and then you'll know when I'm live streaming. The best telescopes are the ones you actually use. Yeah, which is why I think for most people, a Dobsonian is the best starting one. All right, let's grab another question. Karuk X says, do you think we will be able to harvest second stage engines in orbit for material ever? There's actually an even cooler idea which is in the works right now. There's a company called Honeybee Robotics, and I'm actually working on this video. This is 3 videos hence, about a steam-powered propulsion system that they're working on. They've tested it here on Earth, and you could see this future where you've got this spacecraft that makes it to orbit and then goes into orbit or lands on an asteroid, is able to extract just from the regolith of the asteroid enough water to be able to fire a steam-powered engine and spray and push itself around the solar system. And so it could go from world to world in the solar system, just harvesting fuel as it goes. So I think that's the future. Uses electricity from the sun to heat up the water and sprays it out as a propulsion system. And it's those kinds of ideas that can use the resources that are there in space to be able to move around and do things. So I think that's what we're going to really see is more of, and of course, I mean, if you've got space-based manufacturing, then you can totally build second stage rockets, but it might very well be that whole even idea doesn't even matter anymore, that you harvest there's water located in fuel depots across the solar system, and our spacecraft dock with them, refuel themselves, and there's other spacecraft that are dismantling asteroids and creating new fuel and bringing them to these fuel depots. So I think that you can imagine this future where, as we get more infrastructure, the amount that we need to launch off of Earth just goes down. So I like the idea. Am I going to listen to super chats? Let's see. Was there there was a super chat? Someone gave a donation, but the problem is I'm in the midst of answering someone's question. So thank you everybody who has given the donations, and I apologize. The super chats are gone, so I missed the question. So don't just ask your question. I'll answer as many of them as I can, and sometimes they take as long as they do. I apologize. Richard Gonzaga asks, why can't we see black holes? So black holes, of course, are like the most extreme objects in the universe. But the problem is that a black hole, the gravity on them is so strong, of course, that the escape velocity is faster than the speed of light. In other words, everything radiated from the black hole, including light, they might be incredibly hot, but they just absorb all of their own radiation again, so nothing gets out. So this is why we can't see them, and it's kind of amazing the techniques that astronomers have to use to even see them at all. One is to see them interacting with some binary partner. So you might have a black hole that is orbited by another star, and we can see the motion of the star, and that tells us that it's got to be orbiting something very massive. We can see the supermassive black hole at the heart of the Milky Way, and there's nothing there, but you can see stars moving around it like comets going around the sun. And so that tells us that something with 4.1 million times the mass of the sun has to be there to be able to provide that mass. So we have to sort of see this stuff indirectly. And then the other way is with the supermassive black holes that are in the centers of galaxies. We see them because they're actively feeding on material, and it's too much material, and it chokes up and then starts to glow in bright radiation. And so we can see that as material is waiting to die. All right, so Sam Borston's question was, can we build a space elevator on the moon? Yeah. Building a space elevator here on Earth is actually incredibly difficult because it requires a level of materials that we just don't have right now today. Like theoretically, carbon nanotubes organized into cables can be strong enough to provide a space elevator from here on Earth. But if you build a space elevator on the moon, then you only need something that's about as strong as Spectra, which is you can go buy it in the, I don't know, the fancy rope store, and this stuff is strong enough to be able to serve as a space elevator. And a climber that went up from the surface of the moon would be a lot easier, lower gravity, could have the sunlight to power it. So the moon is the perfect place to build a space elevator. Now we just have to think of something to bring off the surface of the moon. And don't say helium-3, because we don't know how to use it yet and turn it into fusion, but maybe in the future we will. But I think that, in Mars as well is similar, which is lower gravity. Theoretically, we can build a space elevator on Mars and be able to, I don't know, bring red dust up and down from the surface of Mars. Tom Deley, could we ever imagine launching a landing rover or even humans to another star system using laser-powered light sail? Did you see the 2 episodes ago that I did, which was the episode about doing a laser-powered probe to Alpha Centauri? That's for a robot, right? Like it'd be a few thousand kilogram spacecraft to go to Alpha Centauri. The problem is you have to shoot it with an incredibly powerful laser, and then the thing spends close to 100 years coasting to Alpha Centauri. So could you put humans on board? Maybe, but they wouldn't have a very fun life, and then they would die. So I don't think it's going to be the technology we're going to be able to use to go to Alpha Centauri. And the reality is, I know this sucks, but we probably will never come up with technology that will allow human beings to travel to other stars in our current form. You can imagine some kind of Genesis spacecraft that 3D prints human embryos when it gets to another world and incubates them and takes life forms and puts them onto other worlds. You can imagine future infrastructure, sending robots to other star systems, but like us hopping in the ship and going to Alpha Centauri is probably never going to happen, which I know science fiction has ruined us for this, and I'm sorry. And that's a Canadian sorry, which is like worth twice. Tammy Bade asks, everyone wants to go to Mars to avoid human extinction in case Earth encounters a catastrophic event. What if humans start living on Mars and there's a catastrophic event on Mars? Well, there you go, right? And there will be a catastrophic event on Mars. We know that in the next 50 million years or so, Phobos is going to crash into the surface of Mars and render it on fire, molten. It's going to be bad. It's going to be a very bad day. And so there's a catastrophic event that's going to happen. The reality is that I can't imagine catastrophic events that we could escape Earth to Mars and deal with. Right? Like on the one hand, you've got like an asteroid strike. Well, if a gigantic asteroid hits Earth, giant asteroids can hit Mars too. And in fact, Mars has no atmosphere. So even small asteroids make a mess on Mars. It's not the best place to go. Here on Earth, fairly large asteroids crash into the atmosphere all the time and they don't make it to the surface because of our atmosphere. If we develop a plague, I guess, some kind of super bug, then the people on Mars will be safe from it. If we have artificial super intelligence, and they're just going to build spacecraft and go get the Martians after they've handled all the humans. So I don't feel like that's a really compelling reason to set up a self-sustaining colony on Mars. I think there's great reasons for us to live in space itself across the solar system in the future. All right. So what was your question? Sam Borston says, will non-claustrophobic space stations with artificial gravity be possible in the next century? I mean, I think I did the math. Like, if you wanted to build the big rotating ring from 2001, you need about 65,000 launches of the BFR, right? So that's a lot of launches of a very large spacecraft. For the longest time, we're probably going to be living in fairly catastrophic conditions in space, in very small, cramped quarters, until we have the infrastructure to build, to hollow out asteroids and get them spinning and things like that. So until then, you're going to be living in a can, tiny little can in space, millimeters away from certain death. Enjoy. Bill Seidel says, would there be a better way to move Phobos into a better orbit? Right. So I just mentioned that Phobos is going to crash into Mars. I think I've mentioned this a couple of times in various episodes. It's because Phobos orbits Mars faster than a day is on Mars. And because of that, the rotation of Mars speeds up and the orbit of Phobos decreases. It's the opposite of what we have here on Earth. Because the moon takes longer to orbit around the Earth than an Earth day, then the Earth's orbit slows down and the moon's orbit increases. The Earth's rotation rate slows down. And so could you fix that? Well, sure, yeah. I mean, if you can put thrusters on Mars and increase it on Phobos and increase its altitude, you could get it beyond the length of a Martian day, and then the opposite would kick in, and Phobos would start to drift outward, and Mars would start to slow down. So all you got to do is just have some technique for moving something that is kilometers across, made of rock. Arjun is asking, how roomy is that Bigelow space pod? Bigelow Aerospace has been making a bunch of these inflatable structures, and their name tells you the size. So I believe they made the B300, which is 300 cubic meters of space, and they've also got the 2000, which is 2000 cubic meters of space. And just as a comparison, that's a little bigger than the entire internal space of the International Space Station. And the key is that you could launch that whole thing in one go. So you just launch more, like double, I think, the internal capacity of the International Space Station, just one launch. You put it on top of an SLS, you launch this gigantic inflatable habitat, you blow the thing up, and you've got a gigantic open space that people can go and live in. So it's a pretty great idea. It just needs to, and there is a sample of it on the International Space Station right now, a prototype, to test out this idea of, does an inflatable habitat work in space? And so far, this thing seems to work great. So I am hoping that people will take that technology really seriously. And I mean, already, I think it's Northrop Grumman is doing a partnership with Bigelow Aerospace to build this inflatable habitat. So it might not even be a NASA thing that gets done. It might just be a private space hotel that gets built. We're going to see a lot of really weird and interesting methods of going to space and staying in space and living in space over the next little while. And we'll see what shakes out. I mean, there's been a bit of a problem in the space mining field. There was two companies. Planetary Resources apparently is in trouble right now, and Deep Space Industries was just bought by a company, and I don't really know the details about that, but it feels like the whole idea of space mining hasn't panned out as quickly as it did. But over the long term, that feels like it's absolutely going to take over. So we'll see what happens. So 420 Ninja says, can you talk about inflatable heat shields and how they could potentially recover second stages? Yeah, there's a really interesting heat shield that's being developed for possible missions to Mars, and they're inflatable. So you've got this ring that deploys and inflates this heat shield and would allow you to get a fairly heavy cargo down to the surface of Mars. And the challenge is that the Martian atmosphere is too thick for you to be able to just fly directly in and land, and it's too thin to be able to really get aerobraking to slow yourself down the way the Earth's atmosphere is. So people have had to come up with really complicated ways to get fairly heavy payloads down to the surface of Mars. And one of the ideas is this inflatable aero shield, where the thing inflates really big and allows you to have a very large aero shield while you're trying to slow down and protect you from the Martian atmosphere as things heat up until you're slow enough that you can land in some other way. But apparently SpaceX doesn't think this is a problem, and the Starship is going to be able to do its own aerobraking and land propulsively on the surface of Mars. And if they can pull that off, that is the solution, right? Josh M is asking who Chad is. Chad is our editor. He occasionally, he's been living in Europe for the last year and a half, but he's actually moving back to Canada in another day. He's actually in airports right now. He may even be watching this right now. I don't know. And Chad and I actually went to college together. He was in my computer science program, and we've been friends for years, and he's been working in programming and video editing. And a couple of years ago, we were working on our videos, and I just got totally overwhelmed, and Jay wasn't able to work on them anymore. And I reached out to Chad, who was doing video editing and video production, and asked him if he wanted to hang out and help us out. And he just did a great job and has been working on these videos now for years. And he's so good. Like in the beginning, I wrote the scripts for my videos, and we put a couple of pictures in there and called it a day. If you go back to the early ones, sometimes our videos have like 10 pictures total while I'm just standing in a forest talking. And now a lot of the videos are 100% videos and graphics, and that's all Chad. He has this now encyclopedic knowledge of where all the cool videos are. He's got them all tagged, so he knows all the source material that he can use, putting in music. And a lot of it is this conversation. Like, I have no idea what Chad is going to do. I write the episode, my wife and I shoot the episode, I upload the raw material to Chad, and then Chad just makes the whole episode. He's the best. He's a beast. I do not know what I would do without him. So all hail Chad. Arjun is asking, why don't more countries launch from countries at the equator? Would that be advantageous in any way? Yeah, the equator is the best place on Earth to launch a rocket if you want to go in the same direction that the Earth is spinning. Because the Earth is spinning at 1,000 kilometers per hour, you get 1,000 kilometers of extra velocity for your rocket, and that allows you to either have a smaller rocket carry a bigger cargo, or your existing rocket carry a larger cargo, or be able to go at a higher velocity. And so it's absolutely the best place to launch. But the problem is that the countries, I mean, most of it is ocean, and then the countries that the equator actually goes through aren't necessarily the kinds of places aren't places that have rocket programs. So there was this one idea that was done a couple of years ago. Raw materials uploaded directly into the chat. I love it. Yeah. So there was this company called Sea Launch, and what they would do is they would have this barge, and they had a partnership with a Ukrainian launch company. It was Boeing, and they would tow the barge down to the equator, and then they would launch their rockets directly from the equator perfectly. And then they would tow the barge back to Los Angeles, and then they would put another rocket on it and tow it back down. And it worked well, but the company eventually, they shut it down. I'm not sure why. I guess I wonder what would be happening. And so it just seems like the savings that you get from launching from the equator don't really match the costs of trying to get down to the equator. Florida is close enough and it's well supplied, and people can work there, and you've got railways and shipping lanes that can bring everything to the Cape and be able to launch all these rockets. Scott Bragdon is saying today's YouTube video was great, Fraser. Scott, are you talking about the QA episode that comes out tomorrow that you saw early because you're a patron? Is that what you're talking about? That one of the benefits of being on our Patreon, patreon.com/universe today, is that you get tomorrow's video today. Yeah, it was a good QA. I was really proud of it, actually. I really enjoyed some of the topics that we get into. And of course, some of the haters are always fun. I actually am slowly gathering a hater special episode that I'm going to do as a QA. So I got a couple of questions now. Every now and then someone says something really nasty, and so I incorporate it, and I'm going to do a whole episode where I just deal with all of those. It's going to be fun. Eric 2000, will I ever retire? No. Why retire? I'm like, why? I've got my dream job. I've been doing it for 20 years. Why stop? I'm enjoying. Yeah, I've already retired. I think that's the key, ideally, is figure out what you love to do and do it for the rest of your life. Done. It just took 20 years to get here. Rami Evans says, do you have an extra Chad to lend me? I'm searching for a visual designer and a video editor. No, Chad is busy, and he will not work for anyone else. I'm sorry. He can't. So, I mean, that's how it works, right? You start out at the beginning of your YouTube career, and you make videos however you can, right? You suck. And then eventually, over time, you are able to bring in a little bit of revenue. And the second you have any revenue whatsoever, you should start to hire people to come on board and and help you with your production work and build up your team. And a lot of the YouTubers that you see out there have people working with them, and that's just how it goes. So in the beginning, sorry, do the work, and then later on, you will bring on more people and build up your team, and you can focus more and more on the stuff that you're good at and less on the stuff that you're terrible at. And I'm glad I'm not there yet, but I know that I get to do a lot more of the kind of work that I enjoy now, and a lot less of the work that I'm not so great at. So find a Chad. Yeah, but your own Chad, not our Chad. Ralph Spring, what would it take for you to shave off your facial hair? I'm not permitted to shave off my facial hair. My wife will not allow this. Go ahead and you go back early. You can see some episodes with me without any facial hair, and she's forbidden it. So there you go. And encourages the shaving of the head. Jesse says, when I join, it says someone you blocked is a moderator here, but I've never blocked anyone, so I don't know what's going on. That's weird. Someone you blocked is a moderator. Weird. And yet you can comment here and see it. That's really strange. I wonder how that happened. Bug, YouTube. Angelo Klin asks, is the plane of the solar system aligned with the Milky Way's plane? Thanks. The answer is no. They are not aligned. And in fact, you can find this out for yourself. So if you go out at night and especially in the summertime when all the planets are up right now, you can see all of the planets lined up. And that's the plane of the eclipse. And you can just see it, right? You just look like there's Jupiter and there's Saturn and there's Mars. And they're all lined up in a sort of an arc in the sky. But really, of course, that's a disk that we're in the middle of. And the Earth is in it as well. But and you can see the Milky Way. And the Milky Way slashes across the sky in a different angle. And so you can see that, in fact, the solar system's direction and the Milky Way's direction are totally different. And the thing that's cool about that is that tells you that, like, we know that all of the planets in the solar system, they're all in the same plane. They form together. There's some event that they're all connected with, right? And they're all spinning and they're all in sort of this connection, while the fact that the Milky Way and the solar system aren't lined up tells you that they're independent, that the Milky Way formed, sort of the whole Milky Way formed with all its stars all together, but the formation of each individual solar system was different in different directions. So it's important to note, and I think I mentioned this before, that Launch Pad Astronomy, Christian Reddy, made our first video way back in the day. And so he was like proto-Chad. He was my first experiment with getting someone's help to make videos. And now he's got his own channel, and he's going to answer a question, and he's really good. So if you haven't already, make sure you go to Launch Pad Astronomy and sign up to his channel. Arjun asks, how happy would you be if Betelgeuse blew up right now? Oh, man, that would be awesome, right? Boom. And it's like it's due to go any day now. And when it does, it will be one of the brightest objects in the sky. Like, not as bright as the moon or as bright as the sun, but it would be visible in the daytime, and it would be just this stunning opportunity for astronomers to study a close-up supernova. And the weird part is that there has not been a supernova that's gone off in the Milky Way that we've seen in modern astronomical history. Like, they know of them that happened several hundred years ago, and we saw a supernova that went off in the Large Magellanic Cloud, or a Small Magellanic Cloud. Anyway, one of the Magellanic Clouds back in 1987. That was the closest supernova that we've had. And in theory, we should be having supernova go off every couple of, every few decades here in the Milky Way. And yet it doesn't seem to happen. So, I don't know what, I can't wait for the next one to happen for us to be able to see it. It's like, I really want that bright comet and I would really, and I deserve that. Like, I deserve a bright comet to be in the sky so that I can see it. And I would really like to see a supernova go off where it was bright enough to see during the daytime during my lifetime. I'm not sure I deserve it. You know, I understand that it could be several hundred years between these events, and my chances of seeing one are low. I also want to see a meteor storm. I've seen really good meteor showers, but I want to see a meteor storm where it's like tens of thousands of meteors going on every hour. Karooks, do you think that we will get past chemical rockets in the next 50 years for launches? No, I don't think so. I think in the next 50 years, we're still going to be seeing, we're still going to be using chemical rockets, because at the end of the day, a chemical rocket is the most powerful way to get a payload off of the surface of the Earth. We've got more efficient systems once you're out in space, like ion engines. Theoretically, there's plasma drives and solar sails and mag sails and electric sails. Like, there's a lot of really exotic technologies that are going to help us move around the solar system, but there's very little that's been developed that will actually get a large payload off of the surface of the Earth. Here we are 100 years after airplanes were invented, and we still use airplane fuel, right? Kerosene. I think you're going to see, it's the technologies. You're going to see reusable rockets. That technology alone. Like, I think people want a space elevator, but the reality is that the BFR, the Starship, is a space elevator. It will be as inexpensive as a space elevator because the thing is fully reusable. That it builds its fuel, it pulls its fuel right out of the air using solar panels to generate methane that goes with the liquid oxygen to launch. That the whole thing, every part of it, is going to be reusable. So I think it's going to be really hard. Once that technology gets developed and is perfected, it's going to be hard to beat that. I'm sure this is what Elon Musk is counting on. And I think the way that it's the thing that's going to beat it, is increased infrastructure in space to the point that there's no need to send heavy payloads from Earth. Stephen Sharmer asks, are there any updates on the Starshade project getting approved? We need this. So for people who don't know what that is, the Starshade is a coronagraph that will be used with future space telescopes like James Webb or WFIRST or LUVOIR or things like that. And it would be amazing to have this. So the thing will fly about 10,000 kilometers away from the telescope and position itself to where the center is perfectly blocking the star. And then you've got these petals that are all around it. And you can see the planets orbiting the star while the brightness of the star is getting blocked. And what's great about these ideas of the Starshades is they can be used by pretty much any space telescope. If there was a Starshade up right now, it could be used by the Hubble Space Telescope, and that would be great. So I think that we are, there are plans in the works, but no one has officially approved launching a Starshade to go along with any spacecraft. Even the LUVOIR or the various next generation space telescopes. So I think that right now it's still an idea. It's been thought through. But we need to see a prototype, or we need to see something get built. It's a great idea. More coronagraphs in space, more better. Paul Franson, I don't see your question, so sorry. But I did see you wondering about your question. The questions come very quickly. There's a lot of questions, which is great. So ask it again. So the creator of TNT says, I want a modular space telescope that is 100 meters wide. Absolutely. Don't we all? And this goes back to that idea of infrastructure and space-based manufacturing, right? Which is that we are entering this time when we can sort of build things in space in a way that there is no no need to worry about how these things are going to handle the gravity of Earth. So you can imagine some future technology where they go and they harness a bunch of material, they feed them into 3D printers, they print out girders in space, they lay out the structure of the mirror down to the micrometer and build this gigantic space telescope in space. And it can be any size. The limits of the space telescopes right now are how big of a telescope you can launch from Earth that can handle the gravity of Earth, can handle the launch, can handle the deployment. That's tough. If you launch something just from Earth, there's only so much you can do. Build the whole thing in space, and you can make the thing 100 meters, 1,000 meters, as big as you want. And then now we're talking telescopes, right? Larry Fields, do you think the Chinese moon landing on the backside is showing fake programs? No. Why? Why would they do that? Why show fake programs? I mean, remember that NASA and the world's other space agencies are tracking. Apparently, NASA communicated with the lander rover. I'm not sure exactly what they did, but no. I mean, conspiracy theories. So now the Chinese are in the conspiracy theory as well, and so are the Russians. Right? Is everyone? Are you in the conspiracy? Who isn't in the conspiracy? Just me, I guess. All right. Trey, nitroline, and what are the consequences of China staking claim to all the helium-3? Well, you're not allowed to... Okay, so one... Nobody can own, according to the Outer Space Treaty, which China has signed, nobody can own any place that is outside of Earth. Furthermore, we don't know how to turn helium-3 into anything with fusion. So that doesn't really matter. If the Chinese could somehow get some kind of mining machine to the moon, like Moon... and start gathering up the helium-3, then I think they're free to gather up as much as they want and turn it into fusion power, and other people will be able to get there as well. So they should just do it. Why not? Yeah, I mean, we don't. This is a part of the Outer Space Treaty, part of like future space law that hasn't really been figured out, which is like what are you allowed to do with resources in space? And so you're not allowed to own, say, land, but you are allowed to use the resources on the land. So, for example, you could land on the moon. I had an interview with Lucian Wolkowicz in this week's Weekly Space Hangout, and we talked about this. That you could land on the moon. You could be a crater filled with ice. You can't own the crater, but you can harvest the ice, and that's really the point, right? Is to get access to the ice. So I think that if the Chinese can get mining equipment to the moon and start gathering helium-3 to build then a whole bunch of amazing things have happened, right? The Chinese have the ability to get to the moon and deploy mining equipment to the moon, and they know how to fuse helium-3. The point of helium-3 fusion is not that it's easier to do fusion. The point is that it produces a kind of fusion that doesn't put out as much radioactivity. So it's the kind of fusion that you would want on your spaceship. But again, I think this is so far down the road that we don't have to worry about it. A bunch of people have been asking about the Event Horizon telescope picture. No update. Spring 2019. Sometime in the next couple of months. Sorry. Let's see. Randy Brizendine, what options for radiation shielding are available in the near future for SpaceX to use to travel through the Van Allen belts in deeper space? Stuff. That's it. You just hide inside stuff and go as quickly as you can and hope to minimize your exposure to radiation. Today, that is the best plan that anybody has. I've done a whole episode on this. People have tried to come up with portable magnetospheres that you can use to protect your ship, and it's just not possible to be able to generate a powerful enough magnetic shield to be able to protect astronauts on board a spaceship. But the plan, like for when the Orion capsule goes to space with astronauts on board, they're going to be watching space weather on the sun, and if there's a problem, they're going to pile up their stuff and they're going to hide in the middle of it for as much protection as they can while the solar storm is going on. And that is, right now, that's the best strategy that we've got. Now, obviously, there are all kinds of things, right? You could use water ice, and water would act as a tremendous protection against radiation. Just a few centimeters of water would be great, but water is very heavy. And so, again, back to future space harvesting of resources, we could build spaceships where we gather water and form a shell that goes around your spaceship and also acts as our fuel source, as our propulsion system. So I think there's some great plans in the future, but we've got to build more of that infrastructure in space. But yeah, water is the best thing. But right now, it's just too heavy. Okay, 5 more minutes. But like I said, I'm going to be on later on, probably working on with the telescope. So 420 Ninja, what's the earliest that we think can become a Type 1 civilization, and what do you think are some crucial steps necessary? So a Type 1 civilization is a civilization that uses all of the energy that falls on the Earth, and you can literally mathematically figure out what the day is going to be that we will have that we will be using all of the energy. It's just a math. You can look at how our energy use is increased, and there's going to be some day, I forget the exact number, but there will be a day, it's like a couple hundred years from now, that our energy use will match the total amount of solar power that falls on the planet. And so back to that whole idea of infrastructure. We're just going to have space infrastructure. We're going to have solar panels orbiting the Earth that will be able to gather up energy and beam them down to the planet, or do manufacturing in space for a lot of the things that we have. What are the games down there? Dominion and Terraforming Mars. The Dominion I bought, and Terraforming Mars was sent to me by National Geographic for their Mars show. They send these crazy goodie boxes when they're trying to promote a new show, and this time they sent Terraforming Mars, which is like a board game, a couple of T-shirts, all the episodes on a little thumb drive, which is really cool. So they really get your attention. Luis Tapia, what medication will we need to take to space? Antibiotics, pain meds? Good question. Probably the same kinds of medication. One of the things that there's a couple of things that when you're in microgravity, you can't stop. The way the fluids redistribute on our bodies, we have problems with our eyesight, and then other things are tougher, like you can work out and rebuild your bone density. And it might very well be that medications are developed that will be able to help you battle some of these problems. And so it might be that if we live in microgravity for a while, we exercise like crazy, and then we take a bunch of medications to deal with some of the other problems. Maybe. Nathan Horner is asking, what is my favorite album? I don't listen to music. I listen to podcasts mainly and books. So I like music, but I like podcasts so much better that I just don't have time. So, if I have free time, like if I'm going for a walk or I'm working out or things like that, I'm usually listening to podcasts. All right, last question. Sam, thank you so much for your super chats. I know I didn't get to them all. And I promise, don't super chat multiple times, because I don't want to make it that I'm only answering questions for people who pay me. So I really appreciate you donating, but that's part of it as well. Is I just want to answer questions for as many people as I can. There's Paul's question. Paul, what's the best argument against flat earthers? Who cares? If you argue with a flat earther, then you've already lost. How can you take a flight from Buenos Aires to New Zealand in a time that is too quick? How do lunar eclipses work? How come people in the southern hemisphere see different constellations than people in the northern hemisphere? It just goes on and on and on. That if you're having a conversation with a person who doesn't believe in evidence, what evidence can you supply that person? It is a paradox. So don't bother, ever. All right, we've reached the end of the hour. That is awesome. I have a great time. Please let me know whether what do you think of these, just me live streaming versus me bringing on guests. I know it's a very different energy, and so I'd love to know your thoughts either in the chat here or in the comments. So let's wrap this up. I really enjoyed. Thanks for all the moderators. Thanks for everyone asking their questions. Thanks for the people super chatting. That's awesome. People donating for me to be able to sit here and talk to you. But as always, keep your questions coming. New QA dropping tomorrow. It's already on the server. And a new episode probably later this week all about the fast radio burst, because a whole bunch of you asked me and it was a great idea. So we did an episode on that. All right. We will see you all next week and maybe later tonight on Twitch. See you later, everybody.